Good morning, students. In the previous video session, we have discussed about the gravitational potential energy derivation. Also, we have discussed the difference between the gravitational potential and the gravitational potential energy. I told you to practice the derivation and note down the 3 mark question difference between the gravitational potential and the gravitational potential energy. Now, today we are going to discuss a new topic, that is water. Gravitational potential energy near the surface of the earth. So, any object which is near the surface of the earth, its gravitational potential energy is U is equal to mgh. This is what we have learned from our lower section onwards. Potential energy is equal to mgh. Any object which is lifted from a height h from the surface of the earth, its gravitational potential energy is equal to mgh. Now we can derive an expression by using the general expression of this gravitational potential energy. U is equal to minus gm on m2 by r. Or you can tell, now for that we can consider, you can go through this diagram on the earth. This earth mass is, you can keep it as me, mass of the earth, and this is the center of the earth. From this center of the earth, you are lifting an object of mass m. So this is what you can consider an earth and a mass system. So here the distance, this is the radius of the earth, RE. You are lifting this object from a height h, and the total distance is r. This is a diagram you can see in your textbook. On an object of mass m and the mass of this earth is ma, you are lifting this object of mass m from the center of the earth to a height h. So the total distance r, you can tell r is equal to re plus h. The total distance lifted this object from the center of the earth is r, and this r is equal to re plus h. Re plus h. And you know the potential energy derivation, general equation, U is equal to minus G m mass of the earth, mass of the system, divided by radius, divided by the distance. Divided by the distance. G, mass of the earth, mass of the system, mass of the system, mass of the earth. That is what ma, then mass of the system m, divided by the distance r. Now we know that r means what? R e plus h, radius of the earth plus h. Now you can keep this equation 1, 2. Now substitute 2 in 1, so what will get out? U is equal to minus g m e m by r e plus. Now what you can do is, you know this thing, this height h height is very much less than the radius of the earth. You see, this height is very much less than the radius of the earth. So what you can do means, we can write this equation 3 like this. U is equal to minus G m e m by, take this re outside. When we are taking this re outside, here remaining what? 1 plus, and here RE is not there, so what will come? H divided by RE you can write. So here you have to write down H is very much less than RE. The height of this object lifted is very much less than the radius of the earth. So you can write down this equation like this. What are, just we are taking this RA outside. When we are taking this RA outside, inside what will remain here? 1 plus this H. Here RA is not there, so divided by RA. Now you can see U is equal to minus GMEM divided by RE. Take this whole term. Now this power is 1. This one power is 1. So take this whole term upside. So what will come? 1 plus H by RE power minus 1. Now you see. Now what you can do is you have to neglect this higher order symbol. So what you can do is we can apply binomial expression. You know this thing, simple thing I will tell you. 1 plus x power n you can write 1 plus x power n you can write 1 plus nx. This you just know. It means here you see 1 plus h by RE power minus 1. Just you have to write this minus 1 this place. The same thing here, this n we have wrote here, nx. The same thing, this power value you write up here. So what will come? 1 minus h divided by RE. Understand that? You see, here we are applying a rule, binomial expression. Nothing that 1 plus x power n, simple expression only. We can just write the 1 plus nx. Just this power value you can write nearby this value. 1 plus x power n you can write, you can put this n down here. So nx will come. The same thing, this power minus 1 you have to write here with this. So minus 1 into plus minus will come. So minus 1 into h by RE is minus 1 minus h by RE. So that is what the binomial expression. So using binomial expression to neglect the higher order values. So what you can do is just write down U is equal to minus GMEM by RE into 1 minus h by RE. Now you have learned your previous videos gravitational constant, a concept of gravitational constant from page number 9. In that you have learned mgre is equal to minus GMEM by RE. So you have learned GMME. So we know that GMEM by RE you can write mgre. So this is what you have learned in previous video session. Gravitational constant GMEM by RE you can write in terms of mgre. If you have doubt in this part, you can go through page number 9, gravitational constant So you will be clear in this. Now we can write this GMME M by RE is equal to MGRE. This you can keep it as equation 4. This you can keep it as equation 5. Now substitute equation 5 in equation 4. So U is equal to minus, instead of GME M by RE, you have to write MGRE into 1 minus H by R. Now multiply this inside. So U is equal to minus MGRE into 1. So minus MGRE, minus into minus plus, then MGRE H into what? H divided by R. This RE cancel. So U is equal to minus MGRE plus MGH we will get. Now finished. Now what you can do is, so this is the equation of potential energy. Now you remember this. Suppose you are lifting an object on the earth from the height h1 to h2. From height h1, you are lifting an object to the height h2. So what you can do is, assume that you are lifting an object from height h1 to h2. Now you can write this equation. U of h1 is equal to, for the height 1 potential energy equation you can write minus mg U of h1 is equal to minus mg RE plus mgh1. This is, you can keep equation 5 and this one 6. Now for the height h2, you can write this equation mg RE plus mgh2. This you can keep equation 7. So we got the potential energy equation minus mgRE plus mgh. We are writing this equation, the same equation 5. We are rewriting this equation in terms of the height h1 and h2. So the potential energy of the object at a height h1 is minus mgRE plus mgh1, and the potential energy of this object at a height h2 you can write minus mgRE plus mgh2. Now you can find out the difference between what? 6, equation 6 and equation 7. So difference between equation 7 and 6. So what you can do is, so we are just subtracting the equation 7 and 6. That is what the difference between 7 and 6. So U of h2 minus U of h1 is equal to minus mg RE. First this equation, h2 equation, plus mg h2, then difference minus of minus this equation mg RE plus what? Here plus, so minus into plus, So plus mgh1. Okay. Now u of h2 minus u of h1 is equal to minus mgre plus mgh2 minus into minus plus mgre minus mgh1. So minus mgre plus mgre cancel, minus mgre and plus mgre cancel. So remaining is u of h2 minus u of h1 is equal to mgh2 minus mgh1. Here mg common, so take this mg outside. So u of h2 minus u of h1 is equal to mgh2 minus h1. Taken this mg commonly outside. So any object which is at a height h near the earth is what u is equal to mgh. So any object, this is an object which is in the earth, you are lifting this object near the surface of the earth at some height, its gravitational potential energy u is equal to always what? mgh. So this is another 5-mark important question. You can see in page number 15. Gravitational potential energy near the surface of the earth. And long answer question number 5. Prove that at points near the surface of the earth, the gravitational potential energy of the object is u is equal to mgh. Page number 44. Question number 5. You can mark this question and you have to learn. Again you remember that the diagram is what? On the earth. From the center of the earth, you are lifting a mass m. The mass of the earth is, we are keeping ma, and we are lifting this mass m. In textbook, one more correction is there in page number 16. The final equation 6.38 u of h2 minus u of h1 is equal to mg into. In textbook it is given h1 minus h2. There is a correction there. You have to write h2 minus h1. Okay. And there is a correction. Now you go through this. You see, assume that on earth, from the center of the earth, you are lifting a mass m upside at a height h. For that we are finding the potential energy derivation. We know the general expression for potential energy u is equal to minus gme m by r. And what is this r? R we are finding from the diagram. You see, this is a diagram and this is center of the earth. From here this mass is lifting. This distance is re. This distance is h. The total distance is r. So what is this r? R is equal to Re plus H. Like that we are finding the distance R. So R is equal to Re plus H. Now we are substituting this Re plus H in this equation 1. So Gm by Re plus H. Now this height of the object lifted from the earth is very much less than the radius of the earth. That is what h is very much less than radius of the earth. So we have to rewrite this equation by taking the Re outside. So while taking this Re outside, here nothing is there, no? So when we are taking this Re outside, here 1 plus h divided by what? Re will come. Now u is equal to gm by Re. And here we are taking this. Now here the power, Here the power value is 1. While taking this upside, it will change into -1. Now, to neglect this -1, what we are doing means we are applying a binomial expression. Here is what? Just 1 plus, you can remember this, 1 plus x power n, we can write 1 plus ns. Just remember this, and we are just writing this -1 here. -1 here. If you want, you can write one more step more. U is equal to minus G M E M by R E 1 plus -1 into H by R. This is what a binomial expression. Binomial, we are applying the binomial expression. So what will come? -1 into plus -1, then -1 into H by R is minus H by R. Now we have learned the gravitational constant of GME by RE, we can write NGRE. So instead of this GMEM by RE, we are writing NGRE here. And what we are multiplying here? So minus NGRE into 1, NGRE, then minus into minus plus, then minus NGRE, then plus, then NGRE into H by RE, RE cancel, so remaining minus NGRE plus MGH. This is the equation. Now we are finding this equation in terms of the object which is at the height h1 and h2. So for the potential energy at the height h1, we can write minus NGRE plus NGH1, and for height 2 we can write minus NGRE plus MGH2. Now we have to find the difference between these two equations, and while finding this difference, what we will get remember this 7 we are subtracting with 6, so 7 minus 6. While doing this, we will get the U of H2 minus U of H1 is equal to NGH2 minus NGH1 we will get. So this is a equation, and from this we can clear that what it is what last you can write any object which is at a height h, its gravitational potential energy U is equal to mgh. And the next part is gravitational potential. Already I told you the difference between the gravitational potential and gravitational potential energy. That is enough. That is important 3-mark question. And now there is an example 6.5 in page number 17. This example 6.5 is one of the important 2-mark question which is previously asked in some exam. Water falls from the top of a hill to the ground. Water falls from the top of the hill to the ground. Why? This is because the top of the hill is point of the higher gravitational potential energy than the surface of the earth. So V hill is greater than V ground. Gravitational potential energy at a height h is greater than the ground. That's why water from the dam and all falling downward. That is one conceptual question previously asked a 2-mark question. Example 6.5 you can mark and study. And next topic is about the acceleration due to gravity. We know this thing. We are studying this acceleration due to gravity from our smaller grade. Acceleration due to gravity. So listen here, acceleration. So assume that we are on the earth. We know that Apple's theory, Newton, how he found out this acceleration due to gravity concept. While he was sitting under the apple tree, apple was falling down. He was thinking about that. Why the apple is falling down, and finally he have suggested that what he has predicted. What the apple is falling downward. The stone I thrown above also falling downward. This whole reason is there is a force. There is a force which is irrespective of mass. Any mass of the object which is falling down on the earth, it has some constant acceleration. And he told it is what? It is the force. It is a force which is acting downward, and this force is gravitational pull of the earth. He told. That is what. So, any object which is falling down towards the earth, which has a constant acceleration, all the object which is falling down with the same value 9.8 into 9.8 meter per second square. That is what you are throwing an object downward. This is a chalk and this is a duster. If you are throwing, this is a two different mass, and you are throwing these two downward, both will fall at a same acceleration. Air resistance you can neglect here. You know this thing. Before also you know one experiment data, feather and hammer from the Pisa tower. The feather and the hammer thrown downward, and finally it is proved. If there is no air resistance, both will reach at the same time. So that is what because any object which is falling down the earth, which is near the earth, it has what? The same gravitational pull of the earth, irrespective of their mass. That is what. Here mass is not a problem, heavy mass or light mass. You throw it down, these two you throw it down and check. Both will reach at the same time at the ground. Because both having the same acceleration. That is what we are seeing, acceleration due to gravity. So the acceleration experienced by the near the surface of the earth, it is what? Acceleration due to gravity, and from the equation F is equal to minus G.P.E by RE. You can write this equation R cap also. G.M.M.E by RE square is the equation, and you know the Newton's second law, F is equal to ma. So F is equal to ma. Instead of this ma, F you have to put what? Ma. So ma is equal to my G. So this is our acceleration, the force on the earth formula. This is a force which is acting on any object which is falling down the object minus G.M.E m by RE. Here mass is irrespective. That is what we are finding now. From Newton's second law, F is equal to ma. So instead of this F, we are putting ma. So you can write it here. This is 1 you can take, this is 2 you can take, substitute 2 in 1 you can take. So ma is equal to minus G.M.E m by RE square R cap. Now here m cancel. So A is equal to minus G.M.E by RE square R cap. And this is what we are saying, acceleration due to gravity, and you can use the symbol G for data, and you can write this equation with only magnitude. This is the acceleration due to gravity, you can use the symbol G, small g, right? Only magnitude. Magnitude means what? The size. No need of this direction and all. G, M, E by R E square. This is what acceleration due to gravity equation. So this equation is very very important in this part. We need this equation for our next derivations. So, my dear students, this you remember, any object which is falling down the earth, it is water. It has some force. There is some force which is acting downward. That's what all the object which is falling downward, and all this object which is falling down have the same acceleration, constant acceleration 9.8 in the earth, and in moon it is different. But in the earth it is water. Every object which is falling down which has the same acceleration, and the force which is acting downward we can write F is equal to minus G.M.E.M by R square R cap direction, and from Newton's second law F is equal to ma, so you can substitute these two in one, so what will get m you can cancel, so A is equal to minus G.M.E by R square, you will get and this is what acceleration due to gravity G. So you can write only the magnitude G is equal to G.M.E by R square. And my dear students, today we have learned the derivation potential energy near the surface of the earth. Any object which is falling water down the earth, its gravitational potential energy U is equal to mgh on 5-mark question. You have to practice. This is also your today's homework, and all of you practice this. Thank you all. See you all. Bye bye.